Hi, I'm Peter Vorobiev. Fiber and zigzag propagation of pump and laser beam tube solid state laser is what I will be talking about, and hopefully the pitch will make this concept clear. The problem with solid state lasers is that as you increase their power using a traditional design, you start encountering problems with the physics. Thermal lensing damages beam quality, heat stress effects become a problem, efficiency wasn't that great to begin with, but it decreases further, and the risk of failure increases. And over the last decade or so, there hasn't really been a breakthrough with solid-state laser power, despite a 42 billion, give or take, market, and the military and the industry both needing megawatt lasers. A good example here would be the Helios laser weapon, which is currently deployed. It only makes 60 kilowatts, so it's good for shooting down drones, but I don't know how well it would do, for example, against a rocket, like an anti-ship missile. So our solution is to dispense with the traditional geometry and pumping scheme. In the traditional geometry, you use a cylindrical working body for your laser and a straight path for pumping, and this creates problems both with your pumping, which is not very efficient, and with your cooling. Our innovation is that pump light spirals inside the working body in a helical zigzag pattern, trapped inside of it by total internal reflection. And this is made possible by the working body being a concentric cylinder. On the left, you can see a single spiral path inside such a working body, but with multiple light sources used for pumping, you can create multiple spiral paths and thus greatly improve the efficiency of the excitation inside your working body. Moreover, the working body as a concentric cylinder with two end caps partially mirrored allows an efficient extraction of the beam and also considerably improved cooling. Better control over amplified spontaneous emission can be achieved by changing the end cap shape. Tubes can be stacked to achieve megawatt power, and off-the-shelf component use in such a design is maximized. The only really not off-the-shelf part here would be the working body itself. The customers of such a product would include Boeing, Raytheon, and all other companies developing high-powered lasers for military and other applications. We have done a bit of a market analysis, and the total available market, which I already mentioned, is about 42 billion, and conservatively the serviceable obtainable market over 5 years would be close to $2 billion. Our team right now is just two people: Michael Savage, an engineer with more than 40, actually more than 50 probably, years experience in multiple areas of engineering, including specifically solid-state laser development for Boeing. He successfully produced multiple patents. And yours truly, I have about 30 years of experience in engineering and applied mathematics, more like 35. And I have worked with both solid-state and chemical lasers and have quite a few patents as well. We will also need to hire a physicist with specialization in nonlinear optics if we want to do some serious R&D. Our business plan considers two paths. The easy way is just to patent our work, which is currently work in progress, and invest what we get from selling patent rights in further R&D. The second path would be to apply for an SBIR grant ourselves, to use that money to develop for a prototype, and then, after we have that prototype, find partners for mass production. And that's it for the pitch.